Okay, it's part 215. Line18x Sterile Neutrinos Transport Particles Oscillate Super-Kamiokande 5G Wow Seti. So the Wow Seti signal there, and Google a mixture model for the fine particle suspensions neutrinos. The thesis comes up about dark matter. Sterile neutrinos as a dark matter candidate. And it's a standard model of particle physics explained with focus on the neutrino sector and order. The model with the right-handed neutrinos, a mixture of Dirac and Marjana. Keywords from this PDF file about sterile neutrinos as a dark matter candidate. Here's a photo of congratulations to Signe Reimer Sorensen, who defended her PhD thesis successfully Thursday, 29th October 2009. After her 3-year PhD studies at Dark Cosmology Center, Signe successfully defended her PhD thesis Thursday, 29th October. And there's a PhD thesis from her. So January 20th, my thoughts. Keywords that stand out in the article about Signe Reimer Sorensen is August 25th, 2006. Signe at darkcosmology.dk, Dark Cosmology Center, Master Thesis in Physics, Niels Bohr Institute, University of Zurich, Neutrino Physics. CIO SERPA analyzed this data for neutrinos transport particles, Higgs-like bosons. We have this come up in Wow Seti, Spectra, Wow Seti, and ASCII, Wow Seti. Poisson-Guesson regime data, Wow Seti. And it says Google CIO SERPA, and this comes up about Spectra. CIO's modeling and fitting application. So there's that. And then Google sterile neutrinos transport particles. And we have the Astrophysical Journal coming up, Neutrino Oscillations and Gamma Ray Bursts by W. Clue. Abstract. If the ordinary neutrinos oscillate into a sterile flavor in a manner consistent with the Super-Kamiokande data on the zenith angle dependence of atmospheric U, neutrino minus neutrino flux, an energy sufficient to power a typical cosmic gamma ray burst, GRB. And then it's got the applications there. Can be carried away from the source by sterile neutrinos and posited in a region relatively free of baryons. Hence, ultra-relativistic bulk motion required by the theory and observations of GRBs and their afterglows can be achieved in the vicinity of plausible sources of GRBs. Oscillations between sterile and ordinary neutrinos might therefore provide a solution to the baryon loading problem in the theory of GRBs. And then there's the conclusions. The Super-Kamiokande collaboration has reported that U neutrinos oscillate in a vacuum into another non-electronic flavor, perhaps into a sterile neutrino. If a significant flux of neutrinos is initially present in GRB sources, the oscillation of V and U into a sterile neutrino would allow the energy to be carried across the region contaminated with baryons and would allow its deposition in a relatively baryon-free region, thus allowing the formation of ultra-relativistic blast. The efficiency of this deposition relative to direct annihilation of the neutrinos when neither the oscillation nor baryons are present is on the order of unity for toroidal geometry of emission and a few percent for spherical or disc-like geometry. In models involving a solar mass compact object, neutron star phase transitions mergers, the oscillation length for the expected neutrino energy of the several MeV well matches the size of the system. For these models, the energy requirements are usually so extreme the toroidal geometry is preferred. In hypernova models, with the characteristic size of the system on the order of thousands of kilometers, GeV neutrino energies are required for this mechanism of energy transport to work. The available power is usually so large that the quasi-spherical or disc-like geometries with their efficiency of a few % suffice. In this letter, I have assumed that it is UV or VU that oscillates into a sterile flavor. The solar neutrino deficit allows but does not require that the electron neutrinos oscillate into a sterile flavor. However, the minimum oscillation length required in this case of about 0.2 AO for MeV neutrinos would be too large to be useful in current GRB models. Okay, so that's the end of that video. We'll go on to the next one.